so that you have an idea of what you're talking about. Okay, so the first statement is already given to us. BF bisects angle AFC. What's the reason for anything that's given first thing? It's always what given, right? And then my second statement, angle AFB congruent to BFC. So AFB, let's label these. So AFB is right here, congruent to BFC, right here. Okay. How can I prove, or how can I show that these two are congruent? What is my reason for that? What do y'all think? Okay, how would that be definition of bisect? Okay, what does bisect mean? Cuts in half. So write this down, everyone. Bisect means cut in half. So if a line is bisecting an angle and we get two equal angles in the statement, then your reason is going to be definition of whatever that word is. So definition of bisect. And make sure that the word you use in here has to be whatever you're given in the question. So for example, if this was a segment and we have the word bisect, can I say definition of midpoint? No. Since you're not given the word midpoint, this cannot be correct. Are we good so far? Okay, the next statement says angle CFD, that's this one right here, congruent to BFC. Well, how do I know that? So you check. If this doesn't help you in any way, you first check your information that you're given to see if it's mentioned anywhere in here. Do we see that anywhere in the question? Yes, no, maybe? What do y'all think? Do we see that somewhere here, maybe? Yes? So what's the reason for that?
Given?
Yeah. Yes, it is given to us, so we can just put given. Make sense? Okay, and then my next statement, BFC is congruent to CFD. BFC is congruent to CFD. Well, it looks like we just went over that. How is this statement different from the one we just talked about? What is it? What happened?
It switched?
Yes, we switched them. We flipped them. So now this is now on the left side and CFD is now on the right side. And what is that called whenever you switch them?
Symmetric?
Symmetric. Thank you. Okay, so let's look at the last one. Angle AFB is congruent to CFD. So AFB is right here. CFD is right here. So if I look at it, well, the picture doesn't help me in any way. It's not given to me in the question, so it has to be another reason, which means I need to look at my previous statements. So I'm going to look at, you first go and look at the two statements right above this one. For example, these two. If I just look at these two statements, is that going to help me in any way to get to this one? So look at it, they both kind of the same thing, they're just different places, right? So that means that's not going to help. So I'm going to go to the one right above them and see if I use these two statements, is that going to help me in any way to get to this one? So this one says AFB is congruent to angle BFC. This one says angle BFC is congruent to CFD. And now we have AFB congruent to CFD. How so? Okay, Do we see anything that's repeated between this statement and this one? BFC is repeated. So anybody who's doing the numbering method? 1, 2, 3. Anybody doing that? So if you're doing that one number, do you give BFC? 2. So whatever is repeated, that will take number 2. If you're not doing the numbering method, you can always use highlighters and highlight the angle that's repeated with the same color. So that's repeated, you're going to give it the same color. And then what numbers are you going to give the other 2 angles? 1 and 3. That's your first and that's your last. And again, you can highlight them with different colors. So that's AFB right here, and that's CFD. So now we're going to look. In this statement, do I have whatever number 2 or whatever is highlighted yellow? Do I see that in here? I don't see BFC, so I'm missing this common side right here. But what do we have? 1 equals 3, which is AFB, this one right here, congruent to 3, which is CFD. So whenever I have one common side that's been replaced, canceled, and we get the first and last terms to equal, which one is that? Transitive. Do we get it? Questions? Are we good? Okay, let's look at the next one. So number 2, I'm given another bisector. BD bisects angle ABC. So here is BD, bisects angle ABC. I need to prove that measurement of ABD is 1/2 measurement of ABC. So as we mentioned before, don't look at what you need to prove because we're gonna solve it step by step first. So what is going to be my first reason? Given, as always. And now my second statement says angle ABD, which is this one right here, is congruent to DBC. How do I know that these 2 angles are congruent? It tells me that there is a line that's a bisector. Well, what does this mean? Cuts it in half, so I get 2 congruent pieces, and the reason is definition of bisect. Make sense? Everyone at home, if you're not getting it, please stop me. I'll repeat it again. And same here as well. Okay, so now the next statement says measurement of ABD equals measurement of DBC. So ABD, DBC, that sounds like something that we just talked about. How is statement 3 different from 2? Okay, besides the measurement. Instead of what? Congruent. Go ahead.
Instead of AC.
So the 2 angles are exactly the same, ABD and ABD, DBC and DBC. Everything is exactly the same. The M is also one thing that's different, but the reason that we added M here, measurement, is because now we're talking about equality instead of congruence. So the congruent symbol became what? Equal sign. What's the reason for that? What do you call that? Whenever you go from congruent to equal or equal to congruent, what's the reason? Definition of congruent. Good job. Would it work if it was the other way around? Equal to congruent? Yes, it is always definition of congruent no matter which direction you're going. Are we good so far? Okay, next one says ABD, this one right here, plus DBC, this one right here, equals ABC, this big angle right here. So remember from last class, we said whenever we have 2 things added, equal to one thing, you always ask yourself that question. Are these the two things that make up this big angle? Are they the two small pieces that make up this? Yes, I see ABD is right here, DBC is right here, and ABC, that's this angle that combines both. So whenever we have this, where we have the two parts adding up to equal the whole, what do you call that? It's an addition postulate. Would this be segment or angle?
Angle addition postulate.
Good job. So pay attention that it has to be in the case where the two pieces are adding to get the whole thing. Make sense? Okay. And then number 5, I have ABD plus ABD equals ABC. Well, that kind of looks familiar to number 4, but let's see if we can find these pieces here and they make up ABC. Well, ABD, that's this one right here, plus ABD, what? That's the same thing, equals ABC. So this be an addition postulate, since I have two things equal another angle? No, since these are not two parts adding up to get this. So what is the difference between 4 and 5? Okay, so let's see. ABD, ABD, that's the same. ABC, ABC, that's also the same, but then what happened to DBC? Okay.
Well, it's like turned around.
It's been replaced with ABD. So is there a relationship between DBC and ABD? Where do you see that? You go to statement 3 and it tells you that ABD is congruent to DBC. So if they're congruent, can they replace each other? Yes. And what do you call that? The reason is whenever one thing replaces another, what is that?
Substitution.
Substitution. I did not replace the whole side, so it wouldn't be transitive. I just replaced one thing from one side in my equation right here. And that thing that I replaced it is equivalent to what I replaced it with. Make sense? Okay, let's look at 5. Here I have 2 times, and this is a multiplication sign, 2 times measurement of ABD equals ABC. How did this 2 just show up right here? Where did I get this from? So my previous statement is ABD plus ABD equals ABC, and now all of a sudden I have a 2 in front of ABD equals ABC. Right, so for example, what's x plus x? 2x, which means 2 multiplied by x. So same thing right here, ABD plus ABD is 2 of ABD. That's what we're saying, 2 of the angle ABD is equal to ABC. So what did we just do? How did I get to ABD here? What did I do to these two? Combine them. So now, why would this be combining like terms and not addition? Because a lot of you were confused. Would it be addition? Would it be combining like terms? What's the difference? Right. So for this to be addition, I have to have added ABD to both sides of my equation. That's what addition is. But if I'm just combining them on one side of my equation, that's just combining like terms. You'll see the difference? So this wouldn't be addition because yes, I'm adding them, but I'm combining them on the same side. I'm adding them on the same side. It would be addition if I added it to both sides. What's another word for combining like terms? Simplify. Good job. Make sense? And now I have ABD equals 1/2 ABC. How did I get this 1/2? Well, if you're not sure, you can ask yourself, if I'm solving for ABD, how would I cancel this 2 that I'm multiplying by? if I need to get ABD by itself?
Divide.
Divide by this two right here. So what does this one have then? If I'm dividing ABD by 2, how do we get this? So if you divide 2 ABD by 2, what do you get? What happens to this 2? What happens here? It cancels out, and then I'm dividing this by 2. So that's one way of writing it down. What's another way? What do we do? Just multiply by 1/2. You're simply saying I'm gonna divide this by 2, which means I'm gonna multiply by 1 and divide by 2. So that's the same thing as multiplying by 1/2, which is dividing by 2. So this one is just division. Do we get it? Okay, so what's my first reason? Everyone say it at once. Given. That wasn't everyone, but it's okay. All right, so the first one says AED congruent to BD, CD congruent to CE. How did I get to statement 2? What's happening here? These congruent symbols change to equal signs. And what do we call that?
Definition of congruent.
Thank you. All right. Then I have AE equals AC plus CE. Well, let's check and see where these pieces are. So AE, that's this right here, equals AC plus CE. So the question you ask yourself, are these the two pieces that make up AE? Yes, whenever we have anything like that, what is that called? An addition postulate. In this case, it is a segment, so segment addition postulate. And then number 4 drove some of us crazy. Let's look at it. I have BD equals AC plus CD. So BD right here. AC is right here plus CD. Are these the two pieces that make up BD? Yes, no? No. Would this be an example of addition postulate then? No, please don't put that there. So what is happening here? It's these two pieces added equal BD. So that means the picture is not going to help me. So I got to look at 1 or 2 previous statements. So I'm looking at statement 4. So let's look at 2 and 3. First of all, let's compare statements 3 and 4. What is exactly the same and what is different between 3 and 4? AC is kept the same. What changed?
AE.
AE changed, and what is replacing AE?
BD.
BD. Is there a relationship between AE and BD? Where do we see that?
In the first 2.
In statement 2, I was told that these two are what? Equal. What about CE and CD? They're equal. So right now I have 2 things replacing each other and they're equal to each other. One of it is a whole side, but the other one is part of another side. So would this be an example of transitive? No. Because remember, transitive is that when you have a whole common side between 2 statements that's been canceled, and now we got the other 2 equal. But that's not the case for this one because we have 2 replacements with their equivalent values. So what do you call that whenever you replace one thing with whatever it's equal to? Substitution. Do we get it? Okay, let's look at the next one. So this one says BD equals BC, which is right here, plus CD, which is right here. So are these the 2 pieces that make up BD? Yes, they are the 2 pieces on line BD. They make up the whole thing. So that's an example of segment addition postulant. And let's look at number 6, which is another one that we got stuck on. So number 6, it says AC plus CD equals BC plus CD. So I know that this is not going to help me, so I'm going to look at my previous 2 statements and see if they're going to help me in any way. So let me erase this. And I'm looking at statement 6, so that means I'm going to look at 4 and 5 right here and see if they're going to help me in any way to get to 6. So you start by reading them aloud, and you see if there's anything that you read twice, for example. So the first one, BD equals AC plus CD. BD equals BC plus CD. So is there a whole side that I read twice? BD. Can I say that I read CD twice and take that into account?
No.
CD is part of one side. It's not a whole side. But the only thing that's repeated as a whole side is BD. And if you're doing the numbering method, that will take number 2. And then what are your other 2 sides? AC plus CD, that's one side. And then BC plus CD, that's my other side. So if I'm going to number them, that's going to be 1 and 3. So in statement 6, do we see whatever we highlighted yellow or whatever is number 2? Do we have BD? No. That common side is gone. I don't see it in number 6. But now what? I have 1, which is AC plus CD, equals 3, which is BC plus CD. So that is 1 and 3. And what do you call that? That is an example of transitive. Alrighty. And then I get number 7. How did I go from 6 to 7? So on the left side, I had AC plus CD. And then I just have AC. On the right side, I had BC plus CD, and now I just have BC.
Subtraction.
I'm missing what from both sides? I'm missing CD from both sides. So I subtracted it from both sides because that's the only way you can get rid of one thing from both sides at the same time, is to subtract it from both sides so that they're canceled. And the reason is subtraction. And now, how do you go from 7 to 8? There's only one tiny difference. What is it? This equal sign now changed to congruent symbol, and you go from equal to congruent, congruent to equal. There's only one reason for that, which is definition of congruent. Make sense?